Finally, we'll talk about another key point to achieve for specific magnetic molecular imaging, the targets. The target imaging means specific diagnosis which may extremely induce misdiagnosis of the diseases. There are two kinds of the targeting, active and passive targeting. The first is the active targeting. In order to achieve this specific targeted molecular imaging, the lesion must have specific biomarker, such as antibody, antigen, DNA, RNA, peptides, enzyme. For example, liver cancer has high expression of AFP, and the breast cancer had high HER2. In addition, the NAND probe should have corresponding antigen or antibody, antisense DNA or RNA or others, which can be bind to the target in the lesion. Using this, the target NAND probe finally reaches the target with high density and achieve the specific imaging and diagnosis of the disease. The image shows that the NAND probes have specific PEG link, which can target to the transport on the surface of the cell and then run into the cell. Through this, finally achieve the targeted drug release, namely targeted therapy, which is similar to the targeted imaging. The second is passive targeting. The common mechanism is that the tumor has rich angiogenesis and its permeability is higher than normal cells around the blood vessels. This can enhance permeability and retention of the contrast or drug. This is EPR effect. Thereby, it may result more contrast stayed in the tumor, and the tumor imaging may stay for a long time. The image shows that abundant blood vessels with high permeability, which cause more nanoprobes staying in the tumor, so the tumor on the skin of the mice shows a high intensity. As we have said, if the nanoprobe has multiple functions of the imaging and treatment, this is multimodal or multifunction probe, which can realize the multiple imaging and therapeutic functions at the same time. And this is diagnostics. For example, a study reports a dual model probe which combined MRI and photoacoustics imaging with gadolinium as the carrier to form a dual model imaging probe. Besides this, the photothermal therapy was performed, and the image shows nice MRI, photoacoustic imaging, and treatment effects. Besides this method, the real-time targeting diagnosis and treatment was successful, which improved the diagnostics of the tumor. This study prepared an MR and PET double model probe with nuclear magnetic SPL as a carrier that construct can obtain simultaneously automatic imaging and function imaging. This study achieves three functions using multimodal imaging. MRI provides the mapping of the whole brain tumors. Photoacoustics imaging gives high spatial resolution and 3D imaging, and Raman imaging provides high sensitivity, specific, and high resolution surface imaging of the tumor edge. Using this method, the accurate and precise diagnosis was obtained. This may provide more comprehensive guidance for clinical practice. So, we get a summary. With fine spatial resolution and excellent tissue resolution, MRI is an ideal molecular imaging technique. Multimodal and multifunctions nanoprobes can success the precise diagnosis and treatment at the same time with better effects, which show nice clinical potentials and need the clinical transformation as soon as possible. In the future, MRI molecular imaging will play an important role in clinical diagnosis and treatment of different diseases. Okay, this is all for this class. Thank you for your attention.